Alright, hello. We are going to be doing some practice questions of Chapter 1 AICE Math, so let's head right into it. Our first question that we have is to express 2x squared minus 12x plus 7 in the form of a times x plus b squared plus c, where a, b, and c are constant, just meaning that we aren't supposed to actually write a, b, and c. This is known as the completed square form, and the way we get completed square is by taking our 2x squared minus 12x plus 7 and first making sure the number in front of x squared is 1. And the way we do that is by factoring out the 2. So we'll get our 2x squared. And we want this minus 12x to sort of stay within this first part of the equation. We'll see as we move along. So we pretty much just factor the 2 out of that 12 as well. So we do minus 6x. So if we redistribute it, we still get minus 12 right there. So we do our plus a blank minus 2 blanks because we're adding 2 blanks here. So we have to subtract 2 as well. Then we do plus 7. So the way we get our number in the blank is that we divide the number next to our just the x by 2. So that'd be negative 3. Then we square it and we put that number in the blank. So that'd be 9 in this case. So we just fill in the rest of our numbers now. We have 2 times x minus 3 squared. Then we have negative 18. We do 2 times 9, negative 2 times 9. Plus 7, and the negative 18 plus 7 is negative 11. So for our answer, we have 2 times x minus 3 squared. And sometimes as a part 2 of this question, they ask what the vertex is. For this one, if you want an example, it would be 3 comma negative 11. Because our x, for that x coordinate, it would flip, but the y would still stay the same. Okay, so next we have find the set of values of k for which line y equals 2x minus k meets the curve y equals x squared plus kx minus 2 at 2 distinct points. Let's break down first what they want us to do. That helps us find our first step and move forward. So typically when we see these words line, curve, and seeing how they meet or how they intersect, that means we're going to be using the discriminant formula. And the discriminant formula is found in the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac over 2a. Essentially, a discriminant is just the b squared minus 4ac, this part right there. Because if the number inside of a square root is positive, that means we're going to get 2 answers. The one that's positive, one that's negative. For example, the square root of 4 would be a positive 2 and a negative 2. On the other hand, if our square root is 0, we're going to have one answer, and that is 0. If our square root is in a negative number, that means we're going to get imaginary solutions. So when they ask for 2 distinct points or they ask for real answers, that means they want this typically. Well, real answers would also include our square root 0. So pretty much what this means is that we want our discriminant to be greater than 0. We want a positive number. So we'll write that up here. Our discriminant needs to be greater than 0. Our first step for this kind of equation, when we want 2 lines we want to find where they meet, we want to make them equal to each other. So we find pretty much the values that would make them meet. So we'd have 2x minus k. I'll make a little line here that we don't get confused with our work. Equals x squared. I need to find that as a plus kx minus 2. And the reason why we can set them equal to each other is because we have y here and we have our y here. Because if we had 2y, then we'd have to resolve it or reorganize it. We need to make sure they're absolutely the same variable, equaling each other. So we start getting them on one side, almost like you would any kind of quadratic problem, make it equal to 0. So we have x squared, that doesn't change at all. We want our x squared to be positive if it can be. Then we have plus kx minus 2x. We're getting that from the left side. Then we're going to have minus 2 and plus k. Alright, so now that we have that, we're going to start plugging values into our discriminant formula, which is the b squared minus 4ac. It works the same way as a quadratic formula, where a is going to be 1, because it's a number in front of x. B, it's a bit trickier, but it's going to be k minus 2. Because another way of writing our kx minus 2x would be k minus 2x, if we just factored all of that out. Then c is going to be equal to negative 2 plus k. So with our b squared minus 4ac, we would write k minus 2 squared minus 4 times a times c. It's a lot to write out, but it's also quicker when you're not doing it on a computer. So we start with our first part, which is k squared, which this would go into minus 4k and plus 4. You can write it down, you can FOIL it out, but we're just skipping that step. We're just going straight into what we would write by the end of that. And minus, well, negative 4 times the 1 would be just negative 4. Then we multiply that negative 4 into the rest of our c, what that is. So negative 4 times negative 2 would be plus 8. Negative 4 times our k would be negative 4k. We have to make sure to do everything, distribute everything. That's an easy way just to lose 1 mark. So now we have all of this. If you remember, our discriminant is greater than 0. So we need to make sure greater than 0, greater than 0. It's going to matter in a second. So now that we have all of our terms, we're going to make sure we simplify them the most that we can. So k squared stay the same, but we have minus 4k minus 4k. So that means you do minus 8k. And plus 12 here, because we have for the 4 plus our 8. So now that we look at this, we sort of see that this looks like exactly like a quadratic. So we're going to treat it as such to find what our k is by the end. Because that's what the question was asking, find the set values of k. So we're perfectly on track for what we're supposed to do. So we're put our 0, it's less than our k squared minus 8k plus 12. We're going to factor this out. We think about what 12 can break into. That would give me 8. Since we see 12 as positive, that means both the numbers we're going to have are going to be negative. That's how we get 8 as our negative number. So we see 12 and 1, we see 2 and 6. Right away, I see 2 and 6. That looks like it'll work. Because we can have k minus 2, k minus 6. And that's how we factor that out. Because the negative 2 times negative 6 would equal a positive 12, but negative 2 plus negative 6 would equal negative 8. So this means when we're trying to get 0 again, we would get k equals 2 and k equals 6. Oh, my 6 is not writing. There we go. Why am I 2 not right either? That's weird. Alright, so we have to remember though, all this was not equal to 0, it was greater than 0. So if we draw our parabola, sort of sketch it out, we would have 2 as one of our answers right here, and 6 as one of them right there. And we sketch that out a little bit, draw our arrows, showing where the line is. So when we see our discriminant is greater than 0, it means we sort of need to use the arms of the parabola, meaning this part and this part. And we see those arms, they're pointing away from each other. We see x is going to be less than 2, and x is going to be greater than 6. So that's exactly how we write it. Oh, not x, our k is that. So k is less than 2 and k is greater than 6. We know it's not greater than or equal to because we definitely need our 2 distinct points. If it just said real solutions, then it would be greater than, but we're looking for just their 2 distinct points, and that is our final answer right there. Alrighty, down to our next one. I've already worked out a little bit of the problem, but it's because it'll take some time to write out. So we just look at our first part. We see express 4x squared minus 12x in the form of 2x plus a squared plus b. We see that x plus a squared plus b is exactly where a completed square form is. But instead of having our x plus a squared, we have 2x plus a squared. So we need to evaluate how exactly that's going to affect our problem. We don't say we can't do this, we don't get overwhelmed, we just try to see how that changes things. So I wrote it out here. X plus a squared simplifies to x plus a times x plus a, which we get this really long form, and then we get x squared plus 2xa plus a squared, right? Then we have 2x plus a. When we multiply that out, we get 4x squared plus 4xa plus a squared, which is really intriguing because in our beginning problem, we have 4x squared. So it shows us we're really on the right track. AICE really wants us to find that out. So we go on and we say, okay, so if the 2x already affects it like that, well, maybe we do minus 12x and divide that by 2. Because 4x squared got divided by 2 in order to appear as 2x squared. Not 2x squared, but 2x right there. So we're going to solve this out. We get 2x squared minus 6x plus a blank minus a blank. Oop, like that. And that's what we have. We don't have a number at the end. You can write plus 0 if you want. I'm not going to write it because I feel like it would just make it more not clogged up and messier. So we're just going to write that simple minus blank. So we do the same exact thing we typically do. We would divide this by 2. 2x squared. If you want to think about it, this is still 4x right here, 4x squared, and we're taking the square root of that, if that's how you want to think of it. But this problem really is a bit of a tricky one. You need to have a bit of math behind you to really intuitively get this. So I would straight up just divide that by 2, divide our negative 12 by 2. That's the way it makes sense to me. So we have minus 9 at the end, and boom, that is the completed square form of that, with having 2x in the front. Our work was taking up a lot of space, so I just quickly shrunk it down a little bit. You can still see it right there if you want. You can go back in the video, pause it where it was at, so we can just have more work to do. 3ii, in which it says, hence, or otherwise, find the set of values of x satisfying 4x squared minus 12x is greater than 7. I wouldn't use completed square here, because in this, it's sort of giving you that quadratic vibe again. So we just want to find the values of x that would make this true. So 4x squared minus 12x. A lot of quadratics, or I'd say rather most quadratics, only work if it's greater than, less than, or equal to 0. So we're just going to simply do that right now by subtracting 7 on both sides. So greater than 0, like that. Now, we can proceed this problem by factoring, because we see that this is a quadratic, but rather, I really don't like factoring when the number in front of a is not just a prime number, like 3 or 2. Those are a lot easier. 4 takes some extra brain power. I don't feel like spending brain power. So we're going to do negative b, well, our quadratic formula, we define a as 4, b as negative 12. On the AICE exam, you'll have a calculator that most likely does this for you, the quadratic formula, but you still need to show your work. So we're going to have negative b, which is negative 12. When you do the math, that turns into positive, plus or minus the square root of b squared minus 4 a c, And that's all that is over 2a. This time our a really matters because it's not just 1, like a lot of other questions. So we can actually just start like solving this manually if you want to. So this would be 12 plus or minus negative 12 squared would be 144. And that'd be negative 16 times negative 7. I don't know that on top of my head. So we're just going to multiply that out in the calculator. That's 112. And we saw a negative times a negative, so that's positive now. So 112 over 8. We can't simplify any of that yet. We still need to simplify our square root right there. And 144 plus 112 equals 256. So we'll write that out. 256, 12 plus or minus, and that's all that is still over 8. The square root of 256 simplifies to just 16. So we have 12 plus or minus 16 over 8. We can automatically divide this by 4. You could divide by 2 and then divide by 2 again, but dividing by 4 is just a bit quicker because it's the greatest common factor. And that is what we have. So when we have our final form of this quadratic state, we split it into one where we take the plus out of our plus or minus and one where we take the minus out of that. I'd like to do the plus first. That's 3 plus 4 over 2, which equals 7 over 2. We can't simplify that further. In this kind of math, you just want to keep the fraction. You don't want to make it a decimal at all. It just makes it a lot easier to work with, especially when you start graphing it. Then we're going to have our minus, so 3 minus 4 over 2, which equals negative 1 over 2. Now let's see what our question was asking again. So we see all this was also greater than 0. So we're going to have, it's really weird to describe. So imagine if you just factoring, you just got your x equals both of those like we had earlier. We graph this out. Oh, I should probably graph that out accurately, so we're going to start with the xy plane. Then we have 7 over 2, which is, we're going to say it's about like right there. Then we're negative 1/2, so it's going to be about right there. Our parabola goes like this. Since we have all this, our whole quadratic greater than 0, it's still going to be the arms. Because we're greater than 0, it sort of means greater than this 0 right here, when your y is 0. So our final answer would be what's less than our lowest and greater than our greatest. So x is going to be less than negative 1/2, or x is going to be greater than 7 over 2. Alrighty, going to our next one. This one says to solve the inequality x squared minus x minus 2 is greater than 0. Alright, this looks pretty standard. This one looks like we can do it through factoring, so we look for what multiplies into negative 2 but adds into negative 1. It means one number is going to be negative, one number is going to be positive. The way we know this is because in order to get a negative number, you have to have a positive multiplied by a negative. If you have negative times negative, you equal positive. Positive, positive equals a positive. So we're going to consider what multiplies into 2 in general. That's probably 2 and 1. And we need to see what adds into negative 1 right there. So that would be probably a well, not probably, it is a negative 2 and a positive 1. If you aren't very familiar with factoring, you can probably look for more practice on that, or you can just simply quadratic formula. Your quadratic formula always works, but it also takes more time, as you probably noticed in our previous problem. But this is pretty much what it would be, because we have negative 2 times 1 is going to be negative 2, yet negative 2 plus 1 is going to be negative 1 for our b. So we equal this to 0, or greater than the 0. You figure out what would make 0, so x could be 2, or x could be negative 1. Alright, and because this is a greater than 0 rather than equal to, our problem does not stop there. If you stopped here, you'd probably get 2 marks out of the 3, so it isn't too bad, but also we really want to get all the marks we can and maximize those. So we have x at 2, x at 1. Our parabola looks something like this. It doesn't have to be super accurate, just sort of a sketch to help you see what you're doing. It is greater than 0, so it's going to be what is greater than the 0 line. We see that x extends to the left of -1, so x is less than -1, and it extends beyond the 2. So, ooh, that was weird. Or x is greater than 2. Alright. So this one, we have that the equation x squared plus px plus q equals 0, where p and q are constants and has the roots of -3 and 5. Whoa, what does this mean? So our roots, in case you forgot that bit of a vocabulary, the roots is where it touches a parabola touches the x-axis. This also be used as solutions or zeros, that's many words for it. So it's going to be right here and right here. So we're saying that one of these is -3 and one of these is 5. So if we sort of work backwards, we can see if x equals -3, x equals 5, we can almost reverse factor this in a really intriguing way. So we have x plus 3, because remember, when we factor, we do the opposite. So we have plus 3 right there, and x minus 5 right here. So right now that's all we know, but right now we need to find the values of p and q, meaning we just need to restore our solutions, our roots, into not a quadratic form, a trinomial? Is that what that's called? I have no, a quadratic? A quadratic. Yeah, that's just generally called. I'm so bad with vocabulary, it's not even funny. But yes, we're making this into a quadratic. So the way we do this is we take our x plus 3 and our x minus 5 and we multiply them with each other. We can do this through FOIL, which is our first number, or component, times our outside, which is x minus 5, so that'd be minus -5x, inside, plus 3x, and the last, 3 times -5, which is -15. And I think I remember how to identify this. It would be a quadratic trinomial. That's why I was getting the words confused. Then we simplify our middle, so it would be x squared minus 5x plus 3. That would be minus 2x minus 15. So we see that p would be -2 and q would be -15. That is the first part of this problem. Alrighty, so this next one says, using these values of p and q, so using these values just means we're using what the math we just did, so x squared minus 2x minus 15 is going to be the answer we sort of continue on with. We're supposed to find the value of the constant r, for which the equation x squared plus px plus q plus r equals 0 has equal roots. So first of all, we need to dissect what equal roots means. Equal roots means, just as though the roots here, we have 2 roots, we have one on the left, one on the right. When we have equal roots, it means the root is the vertex. It's going to hit the x-axis once and bounce right off. So we have just one visible answer. But when we secretly do have 2 answers, they're just considered equal. So when we speak, we just sort of say it as 1. Because we always know something is equal to itself. 2 is equal to 2. 7 is equal to 7. So these roots are equal even if we just view it as 1. So we're supposed to find it for the equation of our x squared plus px plus q plus r equals 0. So we're just gonna rewrite that first. We're gonna symbolize that. That way it looks a little easier to see. So we have this. And if you look, whenever we have our quadratic formula, we have 2 variables in it. We don't like it when we have 2 variables in one equation, because we can never solve it. We can solve 1 variable, 1 equation, 2 variables, 2 equations, that's your simultaneous equations, but we can't really solve this by itself. So we start using the discriminant. So just as this would be a situation, well, it's a bit weird to describe, but the word equal roots also means referring to discriminant, that will be equal to 0. Having two different roots would mean that discriminant is greater than 0. Having two imaginary roots would mean that discriminant is less than 0. So we have x. No, my bad, I'm getting ahead of myself. We have our a as 1, our b as -2, and c as -15 plus r. Remember, we still have to attach that at the end, otherwise we just have numbers equal numbers. We don't really like that when we're trying to solve for something. So we're going to start with our b squared, which is our -2 squared, minus 4 times a times c, -15 plus r. So we'll start solving this now, and we know it's equal to 0, so we don't have to worry about anything else. -2 squared is 4, still equals 0. And we have -4 times 1 is -4. -4 times our -15, let me pull out my calculator. That is 60. So that's going to be plus 60. -4 times r is minus 4r. So, simplify some of this. We have 64 minus 4r equals 0. We're going to subtract 64 on both sides. Essentially, we're just trying to get r by itself at this point. We're going to divide by -4 on both sides. My math is progressively turning slanted, but we see r equals 16. Alright, so find the set of values for m for which the line y equals mx plus 4 intersects the curve y equals 3x squared minus 4x plus 7 at two distinct points. Two distinct points, meaning we have a discriminant that is greater than 0. Because we're having a line and a curve that are intersecting. So we know like pretty much almost right away that we're going to be using the discriminant in this. So we're finding the values of m. Like we said, this is really, really similar to the first problem. We're just going to set our y's equal to each other. So this is mx plus 4, which is equal to 3x squared minus 4x plus 7. And we're going to get them all to one side, keeping the a in front of our x squared as a positive number because it's just generally easier to work with. So 3x squared minus 4x minus mx plus 7 minus 4, which we can simplify this final part into plus 3. I just really don't feel like rewriting the whole equation just for that one part. So now that we have generally our quadratic made, we're going to be using the discriminant now. We are going to define our variables. So a is 3, number in front of x squared. We have b as -4 minus m. Remember, we never want x to be in our discriminant. We want one variable, one equation. That makes us really happy when we're working with it. So now we're going to have b squared. So that's our -4 minus m squared. So b squared minus 4ac. So we'll start solving this. I prefer to put my variable in the front whenever I do this kind of math. So we have -m squared. That is going to be m squared. We would have -4 times -m, which is positive 4m. We'd have that twice, so it becomes 8m. If you want to do this step-by-step foiling, you can, but I prefer to do this a bit quicker, as inherently foiling isn't the main part being tested in this chapter. It's more so the quadratics, the discriminant, etc. So Then we'd have negative 4 times 3 times 3. Do this one step at a time. 3 times 3, that's 9. 9 times 4 is 36. So m squared plus 8m plus 16 minus 36 is going to be minus 20. And of course, this whole time, our discriminant is greater than 0. So this is greater than 0, greater than 0, greater than 0. It just helps at the end so that we don't try to act like, oh, m equals this, while actually being greater than 0 means there's going to be a range. So now we have our quadratic, so we're just going to factor normally. We can break 20 down into 10 and 2, with there being a positive 10, because our b is a positive number, and minus 2. That multiplies in a negative 20, but also adds into plus 8. So m plus 10 and m minus 2 is greater than 0. So from this, m is equal to negative 10 and m is equal to 2. So because we have this little sign here, we're going to draw our graph. We'd have negative 10 over here, 2 right about here, and it's going to be a bit of a thicker parabola. And because our whole equation is going to be greater than 0, this is going to be the arms, so greater than our 0 line. So up here and up here, we extend to the left of negative 10, so our m is less than negative 10. And we extend to the right of 2, so m is greater than 2. And that's our final answer. I was just making sure there wasn't more to solve really quick. But yeah, that's 5 whole marks just from doing all that math, so that's a really nice thing to get on your exam. And then we have number 7, which is to find the set of values for k, for which line y equals kx minus 4 intersects the curve y equals x squared minus 2 at 2 distinct points. So we see line, we see curve, we see intersect. So we know we're using discriminant once again. We're also doing this at 2 distinct points. So we write a note to ourselves that discriminant is going to be greater than 0. So we're going to have our y equals be equal to each other. So we're going to have kx minus 4, and we're going to make that equal to x squared minus 2x. Add all to one side, keeping your x squared positive. That'd be negative 2x right there, negative kx, adding the 4 to both sides, plus 4. We have our quadratic pretty much made, so now we can use the discriminant. We define a as 1, b as negative 2 minus k, and c as 4. So we have our b squared, so it's negative 2 minus k squared minus 4, a and c. We have k squared. We have negative 2 times negative k, which is 2k, and then we multiply that by 2 because there's 2 of them, 4k plus 4. Then negative 4 times 1 times 4 would be negative 16. So k squared plus 4k. So plus 4 minus 16, that'd be negative 12. We're going to factor this out. We think about what would equal 4 when added, but negative 12 multiplied. I think of 6 and 2. More specifically, positive 6 and negative 2. So we're going to do k there, k minus 2. And we see the whole time our discriminant has been greater than 0. Ideally, you should be doing this the whole time, writing greater than 0, but I'm really bad at that. So sometimes you just gotta remind yourself once again of greater than 0. So k is equal to -6, and k is equal to +2. We write our little graph here. We'd have -6 over here, 2 over here. This is generally where our curve would be. And because it's greater than 0, it's going to be the arms up here, greater than the 0 line. So we see k is less than -6 because it goes to the left of it, and k is greater than 2 because it goes to the right of 2. Alrighty, so now we're down to number 8, which is to find the real roots of the equation 18 over x power 4 plus 1 over x squared equals 4. Now right now we notice like a few things are definitely different. We see some fractions in here. We see x power 4 instead of x power 2. Well, we do see x power 2, but we don't see any just normal standard x. What we're going to get through is just one step at a time. Because if you think about it, the way to get rid of any kind of fraction, like say 10/3, would be to multiply by its denominator. That would just equal 10. So we're essentially just going to do the same thing with this. We're going to multiply by the denominator, and we're just going to choose the biggest variable one, so x to the power of 4. The reason why we are going to choose x power 2 is because x to the power 2 times our x power 4 would still leave x to the power of 2 at the bottom. Because if we remember, x to the power of 4 times x to the power 2, on the other hand, that would be x to the power 2, because when we are dividing these fractions, because essentially when you multiply, you're adding this to the numerator, you're going to be subtracting what the exponents are. So on the other hand, x power 2 over x power 4 would still equal x power 2 in that denominator, if that makes sense. And then we're going to simplify this. So we have 18 plus, I'm just going to put this to the side, we don't get confused with it, x to the power 2. Because we had our 4 minus 2 equals to x power 2 equals 4x to the power 4. We need to make sure absolutely everything is going to get this x to the power of 4. That way we make sure everything is still going to be equal. We're not making numbers out of nowhere. So we're going to, like a normal quadratic, we're just going to treat this normally until we have to treat it differently, pretty much. We're going to make this equal to 0, try to keep the number in front of our largest exponent to be positive still, because it's still going to make our lives so much easier. So minus x, ooh, I did this so wrong the way I was doing it. Oh my, now we have a catastrophe. Okay, so minus x squared minus 18. Now we see this, and I think it's going to be best to factor here. So I'm going to do this slide, divide bottoms up method. So we're going to slide our 4 over to the negative 18, x to the power 4 minus x squared, and 4 times negative 18. I do not know that on the top of my head. So I'm being scandalous, I'm using a calculator. We have negative 72. Now, for now, we're just going to factor like this. We're going to worry about our dividing the bottoms up later. So, to get a negative 1, we can use 9 and 8, because those numbers are just 1 apart. And because it's a negative 1, not a positive 1, we're going to make the 9 the negative. So, writing this out, this would be x to the power 4 minus 9 and x to the power 4 plus 8. Now once we're at this stage, this is when we think about dividing and bottoms up. So essentially these steps sort of go together. You do them almost at the same time. So with the divide, you look for the number that can be divided by what your a was, which in this case was, if I can just click away from this, it was 4, right in front of the x to the power 4. So we see, can 9 divide by x power 4? I mean, not x power. Can 9 divide by 4? No, it cannot. So it is going to just be stuck in front of the x power 4. Minus 9, just like that. We're going to keep it like that for now. Now we look at this half. this half can divide by 4. 8 divided by 4 is 2. So, actually we're not supposed to write x power 4 here. My bad. It's a 2 each time. Because x power 2 times x power 2 is equal to x power 4, which is in our original. So x power 2 plus 2 is going to multiply out, because we see 4x power 2 times x power 2, that's going to be 4x power 2 minus 9x, blah blah blah, minus 9 times x power 2, negative 9x. Then we see our outside of 4x to the power 2 times the 2, 8x, that adds up, negative x squared, that's negative 9 plus the 2, we're multiplying those together, negative 18. It's a lot of work, but we see how this is equal to that up there. We could use a quadratic formula here, but the reason why I don't want to is because we don't have x in our equation. We have x to the power of 4. And we see that we can actually still split this. Because if you know what difference of squares are, you'll see that this is it, essentially. We can split both of these into 2x minus 3 and 2x plus 3. So I'm gonna write this out. Ooh, 3, there we go. Because the reason why this works out is because we have a minus, we have a plus, that's going to cancel out any kind of middle thing that just has x there. So our difference of squares is because we have two squares here, and the difference is sort of recognized by the minus sign. So, but we cannot forget this x squared plus 2 that still exists, that still gives us our final answer. So plus 2 is equal to 0. Now, if we are to actually find our x's, we set these equal to 0. So we'd have 2x minus 3 equals 0. So we're going to add 3 on both sides. 3 equals 2x. And then x equals 3 over 2. It's one of our answers. I am not going to do the work like this every single time because we just see some things we can just do a little quick. Oh wait, that was a plus. Oh yeah, I did it right. This one is a minus 3. You make that a bit more obvious. So we... Oh, no, I'm a silly. My bad. This is still the plus. Yes. I just did not see what I was doing. So we subtract 3 this time. 3 equals for 2x. My numbers are slowly disappearing as I get further into the problem. So x equals negative 3 over 2. Now this one's a little peculiar because we would subtract 2 on both sides. So negative 2 equals x squared. And since we still have x squared over here, we have to take the square root on both sides because we want x equals, not x squared equals. So we would get x equals the square root of negative 2, or that would also be recognized as the square, well, pretty much we get imaginary numbers, right? So the square root of just 2i. That's the way we can write this. Wait, I equals the square root, so it'd be wacky. I square root, no, my bad. I'm not used to working with I, so I'm still a student taking AICE Math, please don't be too mean. 2i is how we'd write this. Because I equals the square root of negative 1. Now, if we go back into our original problem, it said to find the real roots. So real roots means real numbers. And 3 over 2 and negative 3 over 2 are the real numbers here. I is not a real number. It's the definition of I is literally the imaginary number. So x over 3 over 2 and negative 3 over 2 are our final answers in this problem. Alrighty, and down for our last problem of the day. We have find the coordinates of the points of intersection of the line y plus 2x equals 11 and the curve xy equals 12. Now this is also in a little bit of a different form, but we've also done this problem before because we see the words line, we see curve, we see our intersection points, so we're automatically going to start with setting these equations equal to each other. And we also know that we aren't looking for a range of values. That's why we don't see any extra variables other than x and y here. We're looking for the coordinates of the points of intersection. So most likely, doing all the work is going to be 3 points, but your final answer is going to give you 1 extra mark, and it's going to be writing them in coordinate form. So we need to remember that at the very end. That's why I'm boxing it in now. If I was taking the exam, I'd probably box it in too. That's very important for an easy mark. So we're going to start by getting this y plus 2x equals 11 into just y equals. You could do it for x equals, but then you have to divide by 2. You have to work with fractions, and we don't really want to work with fractions if we don't have to. So y equals, subtract just 2x on both sides, and boom, you're done. Because if you work with x, you have to do 2 steps, which is subtracting y, then dividing by 2. You can do it, but I don't want to. So then we make this also y equals, so y equals 12 divided by x, because the x and y are being multiplied. And now we set these equal to each other. So we do negative 2x plus 11 equals 12 over x. So we're going to start by multiplying by x on both sides. We want to get rid of that fraction. It's a lot easier if we do that. So we're multiplying everything by x. So we'd have negative 2x squared plus 11x equals 12. Then we see the source starts looking like a quadratic. Surprise, because that's, the whole chapter is quadratics. So, actually, we aren't going to just move the 12 to the left. That's a novice mistake. We're going to move them to the right. That way the number in front of our x squared is positive. It's a little bit more work, but it saves you in the long run. So we're moving the 2x squared to the right. And our 11x to the right. Switching up the signs, that way it works out. And we're going to start factoring this. So this would be multiply that for our slide, divide bottoms up. So that'd be 24 at the right. So plus 24 right there. We think about what would make 11 if added, but when multiply would be add to 24, and one of them needs to be negative because, well, no, both of them need to be negative because our C is positive, yet our 11, our B is a negative 11, so it's negative. We try to break 24 into what we can. I recognize 6 and 4, but that would make negative 10. We see 8 and 3 though, which would make a negative 11. If we make both these negative. So, x minus 8 and x minus 3, but we also need to remember our divide and bottoms up. So we see this. Does the x minus 8 divide by 2? Yes, it does. So we do x minus 4. And the 3 does not, so that's why we make it 2x minus 3. And what were we looking for? Oh, the coordinates of the points. So we need to solve our x. So that would be x equals 4. And x equals, we would add the 3, then we divide by the 2. So those are our x's. That's not our final answer because we're looking for the coordinates. So we're going to plug our x's back into one of these equations. And we already got these by themselves, So I'm going to use this equation. You could use the one at the right, which is 12 over x. I'd recommend that for the first x we got, but the second one is a fraction, and it's really easy just to make a mistake, so we're going to go the simpler one. AICE won't remove marks if you go for the easy route, so make sure to do that when you can. Equals negative 2 over 4. Just making sure I get this equation right. So negative 2x plus 11. And the reason why we're using all equations because it's already equal to y, so we don't have to do any extra algebra. It's just arithmetic. Just put it in your calculator. So it's be negative 8 plus 11, which is y equals 3. So right away, I don't want to work on my next one. I just want to write one of my answers is the x comma the y. So 4 comma 3 if you mess up which x is which with y, for example, I use this x, but this y over here, I lose a mark, and that's like a really easy mark that you can get. Oh, I just deleted that part too. I thought I was going to delete my lines. There we go. So, and our next one is y equals -2 times 3 over 2. That multiplying by the 2 is going to get rid of our fraction, which we always love, we always appreciate, but in reality, you're also probably putting this in your calculator. So it's no worries anyways. -2, so even though these 2's cancel out, the negative is still going to stay. So we'd have -3 plus 11. And that's going to be equal to 8. It's weird how we had the 8 and 3 sort of rotate between these two. So we have 3 over 2, comma, 8. And that's our answer. We have our first one and our second one. Make that clear on your AICE exam that you have 2 answers. So I hope you enjoyed the video. It'd mean a lot to me if you could leave a comment, leave a like, subscribe, do whatever you want. If you have any questions on what I did in this video, if you want to see some specific chapters, you just comment them down below and I'll respond to as many comments as I can. Thank you!